Hey folks, welcome back to another video. Today we're looking at question 143, reorder list. The way we'll be solving this problem is by breaking the problem down into two smaller pieces. We'll first find the middle of the list, and then we'll reverse the second half of the linked list, and then merge the first half with the second half. So what does that look like, right? Let's look at an example. So we have 1, 2, and then 3 and 4, right? So we find the middle of the list. So in this case, we have 3 and 4. And then we reverse the second half, so it will look like 1, 2, 4, and 3, and then we interlace them, right? So it will be 1, 4, right? You take the first node, and then the second first node from the first list, second node from the second list, and then you continue that pattern till everything is done. It's so as long as you understand this, like it's pretty simple. But let's use these like smaller pieces to solve the problem. First things first, let's cover the base case. If head is equal to null, you would return it as is. You'd return it early. The first step here is to find the middle of the list. And how do we find that? We do that by using two pointers. Let's call them P1 and P2. This points towards head, and the next one also points towards head. List node P2 is equal to head. Right, and then like one node moves one node at a time. The second node moves two nodes at a time. So when the second node gets to the end of the list, we know like the first pointer has reached the middle of the list. So while P2 is not equal to null and P2.next is not equal to null, we keep playing, so which is P1 becomes P1.next, and P2 becomes P2.next.next. Awesome. And once we have the middle, now we do the reversing. So whenever you're reassigning values, there are two things that we care about, usually like the temporary value and like the next value. But since we are reversing it, we not just need to keep a track of the current node, which in this case will be P1. And we also need to keep a track of the temporary node. Let's just assign this to null. And then because we need to reassign it, we have like reassign like next value. We also have something called previous, and then this will be null. Awesome. So how do we go about assigning them? So it's while current is not equal to null, temporary list node will take the value of current.next because this is the value that needs to be reassigned. Current.next will be equal to previous, and previous becomes the current node. So this will basically reverse the second half of the list. So what's next? The next part is basically like interlacing them, right? So we have N1 and N2. N2 in this case will be the head, and N1, so N1 in this case will be head, and N2, let's just initialize that below. List node N2 would be equal to, in this case it would be previous. So basically, because like previous like ends with current. Awesome. So in this case, while N2 doesn't reach, while N2.next is not equal to null, you keep reassigning it. So how does that go? We need a temporary node here, so we'll just use like the previous temporary value. So in this case, it will be N1.next, right? So N1.next becomes N2, and in this case, N1 takes like the temporary value, right? And with temp takes a value of N2.next at this point because this is the value that's being reassigned. So N2.next will be N1, which got the value from here, and then N2 will take on the next value that it was supposed to have. So in this case, it would be and 2 equals temp. So in this case, basically, you're switching multiple nodes at the same time, and you should be able to like get the result that we care about. Awesome. Let's try compiling this. Ooh, taking longer than usual. Okay, so basically some so basically it's a time limit exceeded. So it has to be in the while loops. Okay, so while p2 is not equal to null and p2.next is not equal to null, p1.next and p2 is equal to next.next. Yeah, I think that looks fine. Okay, so current is equal to p1, temp is equal to null, previous is equal to null, while current is not equal to null. Temp is equal to current.next. I think I've missed the reassigning here. And then current is equal to temp. So why do we, so temp becomes current.next is equal to previous, yes, and then the previous becomes the current, and the current value gets the next value. Okay, yeah, this is correct. The reason how, like the way I knew that this is wrong is because usually when you reassign values, anything that you start with is what you have to end with. So actually, like, let's try compiling this to see if that actually worked. Okay, yeah, so the first few test cases passed. So one of the tricks that I use when I'm reassigning values is that whatever you start with, you need to end with that, and usually like anything that's being assigned on the right hand value, you on the next hand value it's being assigned something. So that's how I knew that was what was missing. So now we'll try submitting it. Awesome, that passed. Okay, so let's talk about the space and the time complexity. The time complexity of this solution would be of n, because you're iterating through the list multiple times, but just like 3 times, which is a constant number of times, it will be of n. Let's just write that down. Time complexity of n. Space complexity would be of 1, since we're not using any additional space to store any values. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really, really appreciate that. Thanks so much, and I'll see you folks soon. Peace.